Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I am going to discuss about non-exact differential equations. In the previous video, we discussed about exact differential equation. So, what are the exact differential equations? How we can identify the differential equation is exact or not? And we discussed some of the problems about exact differential equations. So today we are going to learn about non-exact differential equations. If you know about the exact differential equations, then we can know about non-exact differential equation. First of all, what is the exact differential equation? So if it is in the form of mdx plus ndy equal to 0, then dou m by dou y it should be equal to dou n by dou x. Then we can say that the given differential equation is exact. So based on this condition, we can identify the given equation is exact differential equation. So how to identify the non-exact differential equation? Otherwise, how to define the non-exact differential equation? We are going to see now. If the differential equation m dx plus and dy equal to 0 be not an exact differential equation. When it will not exact differential equation? If mdx plus ndy equal to 0 can be made exact by multiplying with the suitable function. By multiplying with the suitable function u of x comma y not equal to 0. So here then this function is called integrating factor. So here we are going to multiply with some function. That function is called as integrating factor. So based on this idea, how we can say that this the given equation is non-exact differential equation is dou m by dou y not equal to dou n by dou x. Then we can say that equation is not exact. That equation is not exact. So, if it is equal, that is the exact differential equation. If it is not equal, that is the non-exact differential equation. So, here, how to solve the non-exact differential equations? So, here, we are having so many methods to solve the non-exact differential equation. So, 5 methods are there. We are having 5 methods to solve non-exact differential equation. So here first method is integrating factor by inspection or grouping of terms. First one is grouping of terms or inspection of integrating factor. So why they are telling you about every time integrating factor? If you are multiplying with that suitable function, that is nothing but integrating factor, then only we can convert the non-exact differential equation into exact differential equation. That's why they given reduction of non-exact differential equation to exact differential equation using integrating factors. So here in the first method or first case, we are identifying the integrating factors or grouping the terms. In the second one, we are going to identify integrating factor based on the equation. And in third method, we are going to calculate dou m by dou y minus dou n by dou x by n. That is the condition. Based on that, we are going to find the integrating factor. For the fourth method, here dou n by dou x minus dou m by dou y by m. We are going to identify that. So here we are having homogeneous equation. Based on that, we are going to find the integrating factor. So here also, so like this, we are having the various methods. So in the first method, we are going to see now. So we are having 5 methods. We are having 5 methods to solve non-exact differential equations. To solve non-exact differential equations. So see here, what is the first method? So here, integrating factor by inspection. What is the first method? Integrating factor by inspection. So here, otherwise we can group the term also. So to know this integrating factor by inspection or grouping the term, we should know about the sum of the useful results or some of the formulas we need to get the idea to convert into the form of exact. So see here, d of xy. So we can write this x dy plus y dx. d of xy is x dy plus y dx. d of x by y. d of x by y is y dx minus x dy by y square. y dx minus x dy by y square. d of y by x. x dy minus y dx by x square. x dy minus y dx by x square. So d of x square plus y square by 2. d of x square plus y square by 2, that is x dx plus y dy. x dx plus y dy. d of log y by x. d of log y by x is x dy minus y dx by xy. x dy minus y dx by xy. d of log x by y. log x by y is y dx minus x dy by xy. So these are the formulas you should remember to get the idea to group the terms and to write the values in the equation. Some more formulas are there. You can see here. d of tan inverse x by y. d of tan inverse x by y. So y dx minus x dy by x square plus y square. y dx minus x dy by x square plus y square. And d of tan inverse y by x. d of tan inverse y by x. So x dy minus y dx by x square plus y square. So here we are having x by y. So y dx starting. If you are having y by x, here x dy starting. You have to remember like that. And derivative of, that is d of log xy is x dy plus y dx by xy. x dy plus y dx by xy. Next coming to d of log of x square plus y square. So this is 2 into x dx plus y dy by x square plus y square. 2 into x dx plus y dy by x square plus y square. So d of e power x by y. d of e power x by y, that is y into e power x dx minus e power x dy by y square. y into e power x dx minus e power x dy by y square. So these are the sum of the results we are going to use when you are inspecting the integrating factor or when you are grouping the terms. These are all formulas you should remember. Then only you can identify the form to convert into the derivative form. Then you can identify the non-exact equation to convert into exact equation. See here, non-exact differential equation. So here we are going to solve the non-exact differential equation. So in this method, how to solve, we are going to see by using this example. So given equation is here, solve y dx minus x dy equal to a into x square plus y square into dx. What is the given equation? Y dx minus x dy equal to a into x square plus y square into dx. This is the given equation. So I am going to solve this equation. See here, y dx minus x dy. I am going to divide this equation with x square plus y square. So write down here, divide with x square plus y square. Then y dx minus x dy by x square plus y square equal to a into x square plus y square by x square plus y square into dx. So x square plus y square cancel. Here I can write this one, y dx minus x dy by x square plus y square is equal to a into dx. So if you know this form, we can identify the value. So here we can observe the formulas here. Y dx minus x dy by x square plus y square, where we are observing here y dx minus x dy by x square plus y square. This is the form. So that's why you have to identify this form to write LHS part. So here, what is the formula for this? D of tan inverse x by y. D of tan inverse x by y. So in this place I can write down D of tan inverse x by y. D of tan inverse x by y is equal to a into dx. Now I can integrate this function. Now integrating on both sides. Integrating on both sides. Now integral d of tan inverse x by y equal to integral a into dx. So here already we know derivative is inverse of the integration. So integration and differentiation will be cancelled. Finally I am getting here tan inverse x by y is equal to integral a dx. A is the constant, integral dx is x plus c. So finally this is tan inverse x by y equal to a into x plus c. So here I know this form, then only I can write the formula here. So to convert into this form I am dividing with some term. So these two steps we have to remember properly. You should have the idea about the formulas to write down the terms here. Then only you can solve this type of problems by using the method 1. Is it clear? Now we are going to solve one more problem based on this method. You can observe here. Solve 1 plus xy into x dy plus 1 minus yx into y dx equal to 0. What is the given equation here? 1 plus xy into x dy plus 1 minus yx into y dx equal to 0. So this is the given equation. I am going to simplify this equation to get to the form. So first I am multiplying with the x. So x dy plus here xy into x, that is x square y dy plus here in the second term also y into dx. So y dx minus, so y into y is y square, so y square x dx equal to 0. So here x dy, and already we are having the formulas into the form x dy and y dx. That's why I am writing at one place. So x dy plus y dx plus here x square y dy minus y square x dx equal to 0. So here x dy plus y dx plus here x square y and here xy square is there. So that's why I am taking the common xy. So finally if I take the common in the first term xy, so remaining is x dy minus here if I take the common xy, so y left and dx also is there, is equal to 0. This is only that equation. After simplifying this equation, we are getting here x dy plus y dx plus xy into x dy minus y dx equal to 0. So we need to group these terms to get into the formula form. So see here, first what we are doing, we are dividing with x square y square. After simplifying that equation, what we are getting here, x dy plus y dx plus xy into x dy minus y dx equal to 0. Now I am dividing with x square and y square. Then I can get the form here. So x dy plus y dx by dividing with x square and y square. And here how we can say that we can divide with x square and y square, then we can get the formula. That will be get by the practice only. So it will be depend on the given equation. So based on the given equation, which terms we are going to group and which terms we are going to use to divide, that will be depend on the given equation. You should have the idea to get into the formula form. So see here, plus xy by xdy minus y dx by x square y square equal to 0. 0 by x square by y square is 0 only. So here x dy plus y dx by x square y square. Actually for the x dy plus y dx already we know the formula, that is d of x comma y. What is that? D of x comma y is x dy plus y dx. So we can write this formula directly. But for the second term I need to get the form by dividing the term only. So that's why I am dividing with the term x square and y square. So see here x dy plus y dx by x square y square plus here x will be cancelled and y will be cancelled. Finally I am getting x dy minus y dx by x into y equal to 0. So here, so just now we saw the formulas in place of x dy plus y dx. I can write d of xy. X dy plus y dx is d of xy by x square y square. X square y square plus here we don't have the any other formulas for this form, that is x dy minus y dx by xy. So we can separate the term and to simplify to get the value here, x by xy into dy minus y by xy into dx equal to 0. So here d of xy by x square y square plus x will be cancelled here, we are getting 1 by y dy minus here y will be cancelled, we are getting here 1 by x dx equal to 0. So now we are having the variable separable formulas, so variable separable form, so we can integrate this function directly. So now integrating the above equation. So what we are getting here, integral d of x by xy by x square y square plus integral 1 by y dy minus integral 1 by x dx equal to c. So when you are integrating this is in the form of 1 by x, that means minus 1 by x square. So already square is there, you can write this one as minus 1 by xy, plus integral 1 by y value, integral 1 by y dy is log y, integral 1 by y dy is log y minus integral 1 by x dx, integral 1 by x dx is log x equal to c. So this is our required general solution. So this is the way to grouping the terms. Here first we have to identify the equation. After then we have to simplify that equation to get into the form. So by which value we have to divide, we should get the idea to solve that equation. So after identifying that dividing term, so we can get the formula form to write into the derivative of the d of xy or d of tan inverse xy, like that. What are the formulas we are having here? These are all formulas. This LHS part you should know and RHS part you should remember. So in the equation we are going to get the RHS part, based on that we are writing the LHS part. Why we are writing the LHS part? So integration and derivative will be cancelled. Finally we can get the answer. So that's why these formulas are very important and you should remember those formulas. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.